Hi, I'm Sarah. For the past few days, I've been developing a new BLE scanner app. In this video, I'll go over my data layer, which includes a pre-populated room database. I'll also go over my corresponding JUnit 5 tests. My new app isn't anywhere close to being finished yet, but here's a preview of what it looks like. In my BLE scans, I'd like to include the device name, if known, the MAC address, a list of advertised services, manufacturer-specific data when possible, and a timestamp of when the device was last seen. So here in the preview, we can see we have the device name, the service that was advertised, the address, and when it was last seen, and I also included the RSSI strength. And what's really cool is for Microsoft, we have the company name listed here and Windows 10 desktop, and I'll show you how that works in a second. To be able to show a list of company names and services, I needed to have pre-populated Bluetooth data available in my app. Nordic Semiconductor had just what I needed to make this happen. Available on GitHub, they provide an online repository of Bluetooth assigned numbers. Nordic's database includes JSON files for companies, services, and more. So we've got characteristics, companies, descriptors, services. Here's a snapshot of the company list. I decided that I could store all of this data in Room. That meant that I'd need to have a pre-populated Room database for my app. To get started, I created a new SQLite database with DB Browser. Next, I needed to convert the JSON to CSV. I'm sure there are many ways to do this, but I just used a free online converter. With my CSV files ready, I imported the data into my new database. So you just click Import Table from CSV File. This gave me two new tables, companies and services. And with these tables in place, now I can easily look up data when my app finds a new BLE device. Here's an example of a scan result that's returned from the Android Bluetooth API. So we've got the address, we've got a scan record, we've got service UUIDs, we've got the device name, the RSSI, a timestamp, and some other information here. Some devices advertise manufacturer-specific data, including Microsoft. This example includes the company ID and custom beacon data after the ID. So here's 6 is Microsoft, and then we have a byte array of Microsoft's custom data. Microsoft posts the structure of this data on their site, which allowed me to write a Microsoft parser for my app. So here you can see the beacon data is 24 bytes, and then it breaks down how everything works. To add a lookup for my Microsoft BLE advertisements, I also created a Microsoft device table in my SQLite database. So you can see number 9 is Windows 10. That just left one more table to add, something to store the scanned devices. Here's what the data class looks like. So we've got the device ID, which comes from Room, the name, the address, the RSSI, manufacturer, and then the services is just a list of strings, and the same thing for manufacturer data. And then we have a timestamp for when it was last seen. And here's the SQLite table that stores scanned devices. Some fields can be null, and I added a unique constraint for the MAC address. So here we've got everything laid out. To set things up in my Android app, first I created an assets folder in Android Studio, then added my SQLite database. So here it is here. Next, I created the entities for my pre-populated data. So I've got the company and the service and the Microsoft device. My scan devices entity includes the unique constraint for the MAC address and also includes a list of strings. So here we've got the constraint, we've got our primary key, and we've got the list of strings. My DAO includes queries to get the pre-populated data by ID, insert the new scan devices, select scan devices, and then finally delete all of the scan devices to start out with a fresh scan. Next, I add the entity classes to my database and add in my DAO. Because my scan device class also holds a list, I added a type converter. So here I have my entity classes, a type converter, and my DAO. This type converter converts a list of strings to a JSON string and converts the JSON string back to a list of strings. So here, for these fields, we have list to JSON, which just encodes to string, and then we have JSON to list, which takes the JSON string and converts it back to a list. I like using JUnit 5 for tests, so for this app, I'm using Koin for dependency injection. To create my database in my Koin module, I call create from asset and pass in my pre-populated SQLite database. So here in my provides function, I create from asset and then just pass in my database path. And then I create my database, my DAO, and my repository as singletons. Even though my app might change as I continue to make progress, I wanted to integrate unit testing early on. To do this, I added a shared test module and created some test companies, services, and Microsoft devices that I can use in both my Android and my unit tests. So here I just have a hard-coded list of companies, services, and a Microsoft device. I also created some test devices. Next, in my Android test package, I create my Koin test module. Here, I set everything up as a factory instead of a singleton, and this time I provide my room database in memory. So this has a completely different name, and then I provide my database in memory and create my factories down here. To inject my test modules into each test, I created a JUnit 5 extension. This is a before all callback that takes a var arg array of Koin modules. So you pass in the modules here, and then before each class, it's going to load Koin modules and use the modules that you pass to it. Each test is scoped per class. For my DAO test, I inherit from Koin test, register my JUnit 5 extension, and pass in my test database module. Then I define the classes that I want to inject. And finally, when the test is done, I make sure to close the room database. So always make sure you inherit from Koin test, and then I register my extension and I pass in my test data module. I set up what I want injected, and then I close my database. For my assertions, I insert a device, then I get all the devices as a flow. Then I make sure the device list includes my asserted device. Next, I make sure that I can't insert a duplicate MAC address. And finally, I make sure that I can delete all of the scanned devices. So here, I call my DAO directly and insert a new device, and then I get the flow back, and then I make sure that they're equal. And here, I check the constraint, and then here, I add a few devices, and then I make sure that everything is deleted when I call delete scans. My room database for test is in memory, but I also wanted to test my pre-populated data. To do this, I simply pass in my database module to my pre-populated repository test. So in this test, when I register my extension, I pass in my real database module for Koin. So here I verify my companies, my services, and my devices. That's it for this video. Next time, I'll go over what I have so far for the user interface and demo how the BLE scan works. There's still a ton of work left, but it's getting there. Make sure to stay tuned as I work through this project, and thanks for watching.